Welcome to our video demonstration of QuickSurface. This demonstration is about automatic surfaces of different objects and how QuickSurface handle this. We start with a very simple example like this organic shape, and we just go to Auto Surface. At the moment there are a couple of parameters which we'll go through later, but all you need to do in this moment is you just press preview. The auto surfacing is performed and you can see it on the screen. If you want to see a rendered, you just press spacebar and you can see the shape. And as you can see, this is so beautiful layout that even a human cannot make. And when you're ready, you can just press OK, and this becomes a normal freeform surface which can be edited. You can enter, you can turn off the snap mode, and you can scale it, or you can modify it in a different way, so you can move it around, and when you're happy you just create your own shape. Let's take a look at the next, a little bit more complex example like this one, how this will handle. And this is another dog which is with a bigger number of triangles, around 3 million. And let's try again the auto surface. Now we see that there are a bit more details here, so you can choose an option how the automatic surface can handle this. By default it's set to balance, which creates a normal surface, or you can increase this and make it highest, for example, or you have 4 different levels. And I will just press preview. Just to say that this is real-time demonstrations, I'm not spinning up anything, so you can see how long it takes. Of course, we cannot expect that it just takes 2 seconds. It takes a while, but again I would say this off-the-shelf computer, Pentium i7 with the 16 gigabytes of RAM and nothing really special. We don't have any requirements on the graphics card. It works on the most decent integrated cards and other external cards. We'll wait here. As you can see, this is a complex object. Still it takes a while, but we will see now the results. I just want to mention that another parameter is how many target of quotes you would like to expect, but it doesn't mean that the end result will be this number. The software automatically decides how many quotes he needs to generate, so at the end you see the end result into this field. So now if you want to see the result, you just press spacebar, and I put it quite a high resolution, so that's why it captured a lot of details here. As you can see on the screen, the layout is perfectly balanced and you can accept this. I'll cancel this for now so I can show you a really high resolution surface which we generated, and how it captures the details and how easy it is to generate this. Of course you can see that it's a solid body and you can export this in any CAD file format. Let's move to the next step, and this is another organic shape like this one. It's very simple. I will just remove this, we'll hide this result, something like this, and I will press preview. In this case it's not too complex and it's a smaller object, and then again you see the results. I didn't put a high resolution here, but you can play with this and you can see what it will look like. You can see how it captures the features here, etc. Let's over the next example, and it's another object which may look familiar to some of you. See what our auto surface will do. I'll just leave the settings to default, and we just wait a little bit and to see what QuickSurface will do in this case. Again, it doesn't depend too much on the number of triangles. The automatic surfacing depends really on the complexity, and these are the results. Nice and smooth. And I would like to say that the resulting surface is G2 continuous everywhere and G1 at the extraordinary points. Well, I will load another example for the medical applications like this one, which for the purposes of demonstration I pre-generated this, and we take this curve. Let's look about the details here, what it looks like, and this is my result, which I will just show on the screen. I will press spacebar so you can see it rendered, and this is a solid surface body containing a lot of NURB surfaces, which can be exported in any CAD package. Another example is like sculpture work here. Again, this is pre-generated to save time for this demonstration. We're just reconstructing surfaces, and this is the initial input, and after setting our targeting to a highest resolution, we just create this body. I'll right click and see properties. It contains 60,000 faces, but it's good enough to get understanding for you what the result is. I will open the next demonstration file, which is again a sculpture. Why it's powerful? Because it saves a lot of time, and also it creates surfaces which you cannot create in any other way, regardless if you want to make them manually or automatically. So this is our input file, and then this is our result. You can see it's with the wireframe, how it follows the shape. You press spacebar and you can see the result. The beauty here in our case is that even if it has some issues and it's not a solid body, you can double click and you can use the standard tools to modify and improve your shape. Like you can select and you can isolate for faster visualization. This selecting on the screen, right click and isolate and this is much smaller, and you can focus and reach, and then here you can use normal tools to just take a point, move it around, and then close the shape if needed. Again, I will just hold Alt key, we'll take this in such a way you can close the shape and create a solid body. We'll move now to, and you can continue doing this, we can move now to the next file, which is a mechanical. Let's see what QuickSurface can offer you for the mechanical shapes in the more industrial design, like this one, for example. Of course, you can recreate this with the different lofts and surfaces, but let's see what auto surface will do. I'll leave again the balanced and the medium resolution. I'll press preview. Takes a while, and we need to wait, because although it makes some magic, it still needs time to generate its layout and create these beautiful surfaces. Just expect the result to come soon. And this is how it creates our surface of the mechanical shape. For example, here we can see that the result may not be perfect, and the good thing about QuickSurface is that this is editable. You can just double click and you can hold Control Shift to create a brush tool which will smooth using the mouse wheel I just created smaller, and now this is off, so it's not everything, but it's not on the mesh, so I can use the function which is called snap on the mesh. In such way I can keep my points always on my mesh, and I can see the result, and you can see that I can improve my shape. But automatic surfaces help me really a lot to get to this result which you can see on the screen. Let's move to another mechanical part like this here, how it will handle this. Press preview, wait for a while. In some software people say you need to work with a less number of quads, but we don't agree too much with this, because QuickSurface can handle thousands of quads, and with its optimized algorithm, when we export into other packages, it's optimized them so we get a minimum number of patches. For example, here, if you get something like this, this is not a static result. You can come, you can hold out, you can move your point, and as you see, we close the gap, and now we can see we have our beautiful result. Okay, there is something artificial here. I can come, select it, press the delete key, and we are done. So in such a way you can achieve your results in really short time. Another example, let's see, it's like this mechanical watch. I don't think that this is a good example for auto surfacing, but for the purposes of demonstration I will see what it will do with this type of object. Many people do expect that the software can convert this into revolved surfaces and cylinders and planes in an automatic way. Unfortunately, I don't think it's possible at this moment, at least from our side. So, but let's see for a quick demonstration what the outcome of this result will be. We wait a little bit. It finalizes the shape and we see it on the screen. At any point you can just press the tolerance display so you can see how far your object is from the reference mesh. In this case I just set the 20 microns expectations, and you see the result. I can press space to see the layout, and you can see how it follows the feature lines and what the auto surface is, especially in this area, and you press OK to accept the result. Let's move to the next example, and it's this bicycle helmet. Why I show this? Because it took me around a couple of hours for me to model this side of the shape, and we will try to see how the auto surface will work. Maybe now it's a good moment to say that this is a symmetrical object. I'll just place it in the top view so you see that there is a symmetry. So in this case it's good to use the symmetry option for automatic surfaces. I will just choose which plane is my symmetry plane. The plane is shown on the screen for the user to understand better which plane will define the symmetry. In our case is this bottom plane, and I will leave these parameters. You can play yourself, and I press preview and we wait for a while, and let's see what auto surface will do in comparison with what I have done manually. I would say that with our experiments we have never experienced generation for more than 5 minutes on any complex object. So I can zoom the results. Now I can turn off the symmetry because it's done, and this is my result. This is I'll turn the coordinate system on. This is my result. Hide the mesh, and you can see yourself how well it fits the surface. If I place it in top view, I will just rotate. You see that there is a perfect symmetry of the quartz, and which you can use later for in your design or printing, etc. We'll move to another example of a mechanical part like this one. Let's take a look. I will just create an auto surface very quickly for the demonstration. I know some people would say yes, but this is needs to be designed with a perfect shapes like extrusion, draft extrusion, fillet, etc. But I'm demonstrating this on purpose, first of all, to see how it will look like on auto surface model. As you see, it handles quite well, and I press OK. Now some people will say, well, this is good, but I want a perfect cylinder here. This is not what I expect. I need to fit this in assemblies or milling. So let's try to do something here. I will just use the normal selection of QuickSurface, which is in curvature sensitive, and then I'll press OK, and I will create a cylinder. Now when I have this cylinder, QuickSurface offers some tools to improve this and create a hybrid model. What I need to do is just double click on auto surface and I enter it in edit mode. Now I need to keep the cylinder visible on the screen because our function, which is called offset by reference surfaces, uses all the visible elements on the screen and compensates the auto surface, the generated freeform surface, for the purposes of trimming. And I'm ready to do this. I'll just select my function, and it asks you for a tolerance. Tolerance is how close my points of the freeform surface are close to the primitive, so it can be offset. In this case 0.5 millimeter is okay, and I press OK. What we see here now is that it finds the points and actually push them outward the surface, so this can be used for trimming. I'll press close, and now when I have these two elements, I will just select my freeform surface. I will select the cylinder, and then I choose trim. The trim is initialized, and at that moment you see that our algorithm converts all the freeform surface into a large NURBS patches, which are optimized in such way they're minimum number and much easier to be handled in any other CAD package. In this case I can use just clicking on the screen to trim these, or I will reset the trim. I can use our automatic trimming tool, which uses the reference mesh and some coverage algorithms to define which trimmed sections need to be thrown away. When I am ready, I just press OK. The trimmed surface joins all the remaining surfaces, and it creates our hybrid model. As you can see now, we have this as a cylinder, which can be exported and used, and also we have the rest as a freeform surface. Of course, you can always, because it's a parametric, you can come and you can modify the radius of the cylinder, set it to what you want. When you press OK, everything will be rebuilt and the new model will be reconstructed. I hope you like this demonstration, and thank you for watching.